Okay, let me just show you how you prove the theorem, then we'll be done for the day, right? So the first thing that I'm looking at here is we are looking at you'll be given a circle like this one. I'm going to do it quickly so that we can be fine. Well, it doesn't really look like a nice circle, but it is indeed a circle. Okay, and then this is the tangent, and then let's say this is the chord, like that. And then let's call this point A. We have the point A here, B there, and we have C over there, and we have T there. And the thing that we want to prove, that TCB is equal to A, right? And you'll be given the center here. So the first thing that you need to do is construct the center. Construct the diameter passing through the center. Let's call it F. Then you join F to A. So you have A1. Let me call this one A1 and that one A2, right? And here also we have C, and we constructed what? Let's call this one C1 and C2 there. Now what is happening is that the first thing is to say anything that you want. Anyway, you can say A1 plus A2 is equal to what? It is equal to 90 degrees, right? A1 plus A2 gives you 90 degrees. What is the reason? We're saying these are angles in a semicircle, right? Because remember, that is the diameter there. FOC is the diameter, right? That is the first thing. Then the next thing that we can actually do after that is to say, well, since A1 and A2 are equal to that, we can happily say, well, A1 is equal to what? 90 minus A2. As a result, since that is true, right? So that is 90 minus A2. Then what else do we know? If you look at this, you can actually see that we have what you call, like, we have something. If you look at this, what you are supposed to be looking for is that if you look at A, F, B, and C, they are literally forming what? They are forming a cyclic chord, right? So if you look at A2 is basically equal to C2. So you can say A2 is equal to C2. What is the reason? A2 is equal to C2. As you can see, those are butterflies, and we can say those are angles in the same segment, right? Same segment. Forgive my handwriting. Then after that, since we know that A2 is equal to C2, what else do we know? Now let's talk about C, right? C1 plus C2 is equal to 90 degrees again, right? C1 plus C2 is also equal to 90 degrees if you look at it from our construction. Again, so what does that mean? Why? What's the reason? Is basically the tangent perpendicular to the diameter or radius, right? I'm going to say diameter here. So the tangent is perpendicular to the diameter. So as a result, again, we can say what? We can make, we care so much about C1. So C1 is equal to 90 minus C2. C1 is equal to 90 minus C2. Now, since those are fine, we have A1, which is equal to 90 minus A2, but I'm going to say but, we can also say just say but A2 is equal to what? C2. We have already managed to prove that, so we can therefore say this implies that C1 is equal to 90. Instead of saying C2 there, we can say minus A2. 90 minus A2. Therefore, if you look at that, we have 90 minus A2, which is C1. We have 90 minus A2, which is A1, right? So therefore, A1 equals to C1. Now, if you look at those things, A1 and C1, that is exactly what we want to prove there, right? So we're going to say these are equal to what? 90 minus A2. Those are equal to 90 minus A2. Therefore, the thing that they wanted you to prove is to say TCB is equal to A. TCB is equal to what? BAC. It is equal to BAC. As a result, that ends the proof. Now here's the thing, what you're simply doing is, first off, your construction, in order for you to form the 90 degrees here, I'm gonna use a different color because it's no longer part of the solution. You are constructing to form 90 degrees here. From that 90, you know that this part C2 and C1 is equal to 90 degrees, right? So that was the part here. And then you can then make C1, because our concern is about C1, right? Make C1 the subject. One thing down. The second thing, you constructed by drawing the very same line and joining A to F, you manage to end up with the fact that this A1 plus A2 gives you 90 degrees for the same reason, for this particular reason, right? So we're saying that. So as a result, we are so much concerned about A1, and then you're going to say 90 minus A2. So that makes us, that takes us here. The third point is to just talk about the angles in this same segment, A2 being equal to C2, right? Then since we know that A2 is equal to C2, we can now substitute, right? We are saying but A2 is equal to C2 here, since we know that C1 is equal to 90 minus C2. So C1 can actually be equal to 90 in place of C2 there. We're going to put A2. So if we look at that, 90 minus A2 and another 90 minus A2 over there, it is basically what we wanted. So A1 is equal to C1. And basically that is it. And they are equal to 90 minus A2. Then you can actually rewrite your things in the proper way. So basically that's it. And this marks the end of the proof.